Welcome. Nope. Welcome. Yeah, no, we started. Good start. Welcome, Honors Algebra 2, to your 3.1 Part 2 notes. So we are going to be finding the domain of different types of functions, which this is going to be a little bit of a review, which yay. So remember, domain, we talked about the domain of rational functions in our first section. So one of our first units, we talked about finding the domain of a rational function. That's where it was a variable in the denominator. So let's actually start with that one. And I'm going to write this in different color. So a rational expression, an example of a rational expression is something like 5x over x minus 8. And remember, the domain, whenever we're talking about the domain, we're talking about what x values work for this. Now, with a rational function, it's easier for us to think about what x values don't work for this. And remember, the x values that don't work for this are the values that make the denominator 0. So a rational expression cannot have a denominator that equals 0. So what we need to do is find the excluded values. So to find the excluded values, oops, I'm running out of room here. We're going to make it work. We set the denominator equal to 0 and solve for x. And remember, we always write this in interval notation. That's super, super important. And so all of these are polynomials, radical, and rational. We write all domain needs to be written in interval notation. Interval notation. Okay, so I'm just going to, for right now, I'm going to skip 1 and 2. And I want you to look at 3, 4, and 5. Not 6, just 3, 4, and 5. And from those 3, 4, and 5, which one of those do you think is a rational expression or a rational function? And if you're thinking 4, you would be correct. 4 is a rational expression. So first, let's label it. This is a rational. So to find the domain of this function, what we're going to do is we are going to find the excluded values. So we're going to take the denominator, because remember, with rational, I only care about the denominator, which my denominator here is x squared minus 4. So I take the denominator, x squared minus 4, set it equal to 0, and solve for x. So I can add 4 to both sides, take the square root, and I get x equals plus or minus 2. Now remember, those are my excluded values. And hopefully you guys remember this from before. So if it helps, remember to graph this when we're trying to write this in interval notation, let's graph it. So it can't be equal to -2, and it can't be equal to 2. So that just means that it can be equal to everything else except those values. So the way that we write that in interval notation is saying, okay, it goes from negative infinity to negative 2, parentheses, because it can't be equal to negative 2, union, parentheses, negative 2 to 2, parentheses, union, 2, parentheses, to infinity. And so that would be the way that we'd write the domain for this function, because that's saying, okay, it can equal every single number, any input works for this function except negative 2 and 2. So my domain is essentially all real numbers except 2 and negative 2. Now, could you have solved this by factoring? Absolutely. It's a difference of squares, x plus 2 and x minus 2. You get the same thing, whichever way you want to solve it. But again, those are my excluded values. Okay, so rational function, that should be a review. Let's look at polynomials. So let's go back up and look at polynomials. So an example of a polynomial is something like x squared plus 3x, or x cubed plus 27. Essentially, a polynomial is anything with a variable in it that doesn't have a fractional exponent, which makes it a radical, or a negative exponent, which makes it a rational. So polynomials, there's a pattern for polynomials and looking at the domain. So I'm thinking, what x values work for this? Or sometimes it's easier, like with rational, what x values don't work for this? So I'm thinking, I can't think of anything that I could plug in here that would make this not work. And so polynomials are actually the easiest of these. All polynomials will have a domain of all real numbers. So all polynomials will have a domain of all real numbers. So how do we write that in interval notation? Well, it's basically saying negative infinity to positive infinity, so that's how we write it. Negative infinity to positive infinity. All real numbers. So no matter what type of polynomial it is, if one of the variables, like if there are only positive exponents and no fractional exponents, is considered a polynomial. And so it will have all real, or the domain will be all real numbers. So if we look between 3 and 4, going back down here, look between 3 and 4, which of these functions is a polynomial? And if you're thinking 3, you would be correct. So when I can categorize something as a polynomial without doing any math, I don't have to think about what the domain is. The domain here is all real numbers. So negative infinity to positive infinity. And that's all you have to do. So when you can categorize something as a polynomial, you don't even have to think. You just go, yep, domain's all real numbers. Okay, last one is going to be a radical. So a radical, an example of a radical is something like the square root of 2x minus 5. Now again, with a radical or with any of these, we're thinking what values don't work. So basically, what values would make a square root not work? A positive number? No, that works. 0? No, we could take the square root of 0. What about a negative? Well, we're only dealing with real solutions here because on a graph, you're only talking about real solutions. So a radical, you cannot take the square root of a negative number. Let's first write that. You cannot take the square root of a negative number. So to find the domain, I don't know if you guys can hear the air conditioning making annoying noises, but I can. So to find the domain, what we do is set what is inside the square root greater than or equal to 0, and then we solve for x. So we set what is inside the square root greater than or equal to 0, then solve for x. So in this case, we'd set 2x minus 5 greater than or equal to 0 and then solve for x. Because we want this, the inside of the square root, to always be either 0 or higher, so greater than or equal to 0. So if we look down between, well, our last one is 5. 5 is an example of a radical function. So to find the domain of a radical function, we set the inside. So in this case, the inside is that 5x minus 10. So all we care about is the inside. We set 5x minus 10 greater than or equal to 0, and then solve for x. So add 10 to both sides, divide by 5, and I get x is greater than or equal to 2. So now we want to write that in interval notation. If it helps you guys to graph it, then graph it. That's at 2. It would be a closed circle going in the positive direction, or bracket. And so we look, it starts at 2, goes to positive infinity. And so that is our domain. So every single number will work from 2 on that will make this positive. If I put in something like 1, 5 minus 10 is negative 5. We can't take the square root of a negative number and get a real solution. 0, if I plug in 0, 0 minus 10 is negative 10. The square root of negative 10 doesn't get me a real solution. So those are your 3 different functions that we're going to be focusing on for this unit. Now, you can also, without like just telling what it is, we're going to look at number 1 and 2. So number 1 and 2 says determine if the equation is a function, then find the domain of each function, if it is a function. So what I want to do is I'm actually going to graph these. So I'm going to open up Desmos, which is this app, which, oh, there it is. Okay. And I am going to graph this equation. Y equals x squared minus 1. Now, just by looking at the equation, I can tell what type of function this is. Is it a polynomial? Is it radical? Or is it rational? I can tell you this is a polynomial. So first, before even looking at the graph, I know it's a polynomial and I know what my domain is going to be. I also know, just by looking at this, it's a quadratic. So I know my graph is going to be a parabola. So looking at this, we can look to see, first, is this a function? Is a parabola a function? Remember from our, oh, now I'm getting a text message. Apologies. Okay. Watch, we're going to get one more. So remember, for it to be a function, it has to pass the vertical line test. So I'm looking to see, does my pen or my pencil or vertical line go through this graph more than once? And it doesn't. So this is a function. Now let's think about the domain. Now we know what the domain is. It's a polynomial. It's going to be all real numbers. But let's look at the graph too. Remember, domain is my x values. So we're looking at it from left to right. Where does it start? Where does it stop? And really, I could keep going to the left side and it would keep going I could keep going to the right side and it would keep going. It goes on for the left forever and it goes on to the right forever. So my domain here, just like we know, is all real numbers. Okay, I just got like phone calls, text messages. Okay, so I just had Miss Curry apparently had an emergency that I needed to attend to, which wasn't an emergency. Okay, so because it's a function, it was also all real numbers because it was a polynomial, and so that is my answer. Remember, it was a function because we know, okay, the graph of a quadratic is a parabola. And a parabola will always pass the vertical line test. Okay, so let's look at our other function, x squared plus y squared equals 9. So let's graph that. Now, this is kind of throwing it back to geometry. Some of you might know what this graph is going to be of, but let's graph it. So if we were to type in x squared plus y squared equals, what was it, 9? Yeah. 9, we get a circle. And so this is a graph of a circle. So first, is this a function? Is that a function? Does that pass the vertical line test? No. So 2 ways that we can know this. 1, we know that x squared plus y squared is always going to be the graph of a circle. So that is not a function. Or 2, we can also know, okay, so first we can know that graph is a circle. And does not pass the vertical line test. And an easy way to tell is a y won't be squared in like a function will never have an even exponent on the y. So also that, like, if you look at that and you see a y squared, a y to the 4th, like, you'll never have an even exponent on the y. So a function will never have an even exponent on the y term. So, oops, okay, you can't see that. Okay, so it's not a function. If it's not a function, we don't have to find the domain. But if we were to find the domain, let's look at the graph again. If we were to find the domain, again, domain is always looking at something from left to right. So from left, the farthest it goes is -3. And then from right, the farthest it goes is +3. So we would actually write that domain as bracket -3, comma bracket 3, or -3, comma 3 with brackets on either side. And that would be the domain of my circle. Okay, so last problem to look at the domain is 6. So is this one a polynomial? Is this a rational function, or is this a radical function? And you're probably thinking, it's a rational, it's a radical. And you're both right. It's both of those. It's a radical because of the square root. And then it's a rational because there's a square root in the denominator, or there's a variable in the denominator. So what we have to do is take into consideration both, like, restrictions. A radical has to be greater than or equal to what's inside the square root, which the top is already positive. So we just have to make sure that the negative, or the bottom, is also positive. Because if the bottom was negative, then we couldn't make this like positive at all. So we have to make sure that the bottom is greater than or equal to 0. Well, for it to be rational, we also like make sure we set the denominator equal to 0 and solve for the excluded values. And we make sure, okay, the bottom can't be equal to 0. So let's put that together. X minus 4 has to be greater than or equal to 0, and x minus 4 can't be equal to 0. So if we combine that, greater than or equal to 0 and can't be equal to 0, we're just left with greater than 0. So again, it's not or equal to 0 like it would be in a radical, because the denominator cannot be equal to 0. So it's just bringing two things together and thinking about it as one function. So we just solve for that, add 4 to both sides. I get x has to be greater than 4. And then we write that in interval notation. You can graph it. You don't have to. Let's graph it to help. Greater than is an open circle or a parentheses going in the positive direction. So to write that in interval notation, it starts at 4, goes on to infinity. Open circle is parentheses. Infinity is always a parentheses. And that's it. So that would be the domain of this function. Okay, let's move on to the second page, and then we're done. Okay, so number 3 says if a rock falls from the height of 20 meters on the planet Jupiter, its height h in meters after 8x seconds is approximately h of x equals 20 minus 13x squared. So it's essentially giving us a function. Now, before I do anything, I like to kind of just like think about what it's giving me. It's telling me that h is talking about height in meters. So it's giving me h of x, which we know from the last notes, h of x or f of x or g of x or anything of x is the same as y. So h of x or y is talking about the height. I just like to I think labeling what each variable represents really helps me to kind of figure out what I'm looking for in each question. And then x is representing seconds. And then we have our function. So our function, and if you guys would prefer, instead of writing h of x, we can just use y equals 20 minus 13x squared. So if you're more comfortable with y, then rewrite it as y equals. Doesn't matter. Okay, so A says, what is the height of the rock after 1 second and then after 1.1 seconds? So we first want to figure out, what is it asking us to find? Is it asking us to find our x value, or is it asking us to find our y value? Well, it's saying, what is the height? So it's asking us to find the height. So it's saying solve for y. Well, we need an x value to be able to solve for y. So it's saying after 1 second. And that's giving us seconds. So it's giving us our x value. So solve for y when x equals 1. And then also when x equals 1.1. So all we have to do is plug it in. So for 1, we just plug it in. Y equals 20 minus 13 times 1 squared. Remember, we do our exponents first. So 1 squared is 1. And then 13 times 1 is 13. 20 minus 13 gets me 7. And so that means 7 is the height. It's in meters. So 7 meters would be my answer here. So after 1 second, the rock is going to be at 7 meters, which makes sense. It's positive. It would be weird if it was negative. That would be unrealistic. That would not be a height. So we're still thinking about it in terms of like, does this make sense? Okay, so now let's figure out after 1.1 seconds. So what I want you guys to do is try this on your own. So take that x value, plug it into your function, and get your y value. So pause me here, try this problem on your own, use your calculator to help you. Now remember, with this one, exponents first. So when we plug this into our calculator, we're doing 1.1 squared and then multiplying it by 13. And then I'm going to do 20 minus that number, which is 4.27. So y equals 4.27 meters. Now, let's think about that. Does that make sense? So after 1.1, the rock is falling, so we're like dropping it. Would it be higher or lower after a little bit more time? Well, if you're dropping something after a little bit more time, it should be lower to the ground, which it is. It's 4.27 meters from the ground, so that makes sense, which is less than 7 meters. Okay, so let's look at part B. Part B says, when is the height of the rock 15 meters? When is it 10 meters? So first thing what is it asking us to find? Is it asking us to find seconds, or is it asking us to find the height? Well, keyword, when. So when is asking us for the time. So it's saying solve for x. Well, if I'm solving for x, I hope I have a y. So solve for x, and it says the height of the rock is 15. Well, height is y. So that's saying when y is equal to 15. And then when is it 10 meters? So and when y is equal to 10. So let's start with y equals 15. So that means we're plugging in 15 there. 20 minus 13x squared. So I'm just going to start to solve for x. So I'd subtract 20 from both sides, and I get negative 5 equals negative 13x squared. Divide both sides by negative 13, and I get 5 over 13 equals x squared. And then to get x by itself, I'm going to square root both sides. Now, because we're dealing with a real life type situation, hypothetically speaking, well, since we're dealing with a word problem, we want to answer it with decimals. Typically, I would say leave your answer in fraction form, but when you're answering word problems, you typically want to write them as decimals. So we are going to plug that into our calculator. Take the square root of 5 divided by 13. Notice that the 5 over 13 is both inside. They're both inside the square root. And I get 0.62. So x equals 0.62. Now x is in seconds, so it's 0.62 seconds. Okay, so now we found it for 15. What I want you guys to do is solve for x when y equals 10. So I want you to do the same thing, but now solve when y is equal to 10. So pause me here, try the problem on your own, and then come back and check your work. So I started by just plugging in 10 in for y, and now I'm going to start to solve for x. So I solved for x squared. Now I'm going to go ahead and square root both sides to solve for x. And I got 0.88 seconds. So does that make sense? When it's like a smaller height, is it going to be less seconds or more seconds? Yeah, that does, because it's dropping. Again, it's dropping. This rock is like up here, and it's going down to hit Jupiter. So when the height is here, more time has passed than versus like right here. So that would be my answer, 0.88 seconds. Now you may be wondering, okay, well, what about, we know when we take the square root of something, it's plus or minus. So plus 0.62 seconds minus 0.62 seconds. Well, there is no such thing as negative time. So we only take the positive side of that. Okay, last question, part C. When does the rock strike the ground? So first, we've got to think about what is it asking us to find? The x value or the y value? So I'm looking at when. Again, it's when. So when is asking me for the time. Now the time, so solve for x. When what? Well, the height, we need the y value. And it says when it strikes the ground. What's the height when it hits the ground? Well, that would be 0. So it's asking us to solve for x when y equals 0 because it's telling us strike the ground. Whenever you see strike the ground or the floor or whatever it is, that's typically telling you y is equal to 0. So go ahead, it's just like this problem. Instead of 15 or 10, y is now equal to 0. Go ahead and try and solve this problem on your own and then come back and check your work. I just started by plugging in 0 for y. Now that I've solved for x squared, I'm going to square root both sides. And I get that x is equal to 1.24. And you can round to 2 decimal places, just like I did here and here. We're going to round to 2 decimal places. And so x is seconds, so 1.24 seconds. Which again, does that make sense? More time has passed than when it was at 15. More time has passed than when it's at 10. And then the most amount of time has passed when it finally hits the ground. So yeah, that does make sense. Okay, so that does it for this problem, and that does it for the 3.1 notes. Remember, if you guys have any questions, you guys can bring them to class and we can go over them, and we'll of course do more practice with these. Have a great day, and I will see you guys soon. Bye, guys.